Hi class. I want to take a few minutes and go over some material that applies to your week 3 homework. Some of this is somewhat of a review from the data types we did last week, but I want to make sure that you guys have this information so that when you get to task 5 you don't get too frustrated. Because with task 5, not only do you have to write a bunch of if statements to make sure that you get the right values based on the logic you have to create, but you also need to use the correct data types in order to have the right level of accuracy in your program. Now what we're talking about, right, is numeric data types come in a couple different flavors. We've got our integers, our floats, we have decimals, and we have fractions, right? Now each of these data types have accuracy levels with them. Integers, pretty blunt, right? They're just whole numbers. A float is a value with what you look at it and you see decimal point values after it. But you have to remember that when you're using a float, you're really working closer to the computer's native ones and zeros type of math. So a float is a binary type of decimal object. The integer type, now this is more of a number that like you're used to working with from math classes, right? Where you've got 4.123, right? It's got 4 decimal places after it. But what can happen to you is when computers are converting what we're used to working with in decimal form, is when it converts that to a binary, you get different numbers, right? There's because the way the computer's working. A case in point would be 0.1. To me and you, if I add 0.1 to 0.1, I get 0.2, and I add another 0.1, and I get 0.3. But if you're working with floats and you try that, you're going to get something that you don't recognize, and that's part of the float math, the binary math that's taking place. Here, let's give you a quick example here, right? So we'll do 0.1. Let me get into Python here. So I say 0.1 plus 0.1 plus 0.1. Alright, you see, already that's not exactly 0.3, right? It's got this way down here on the end. It's got a 4. And that's a direct result of the fact that this is binary math taking place. So what would happen if I took this and I said, let's add, or actually, let's subtract 0.3. Now, if we're working this on paper, we would expect to get 0, right? But look at that, we're not getting 0. We're getting this number that's got a whole bunch of zeros in front of it. Note we're using switch to scientific notation here, or E notation, but it's got the minus sign, so that means this decimal point is actually way off to the left with lots of zeros there. But again, it's not actually 0. It's something else. It's a very small fraction of 1, but it's not 0. So we can actually switch just to the decimal data type, right? Because a decimal data type is going to work with the numbers in their more native decimal form, and it's going to do all of the math trickery for us. That's a really handy thing about having the decimal type in Python. So here, let's try that same example again, but this time I'm going to use decimal values. Actually, before we get to that, let's talk a little bit about using the decimal object, because there's some things about it that can trip you up, honestly, and it trips up Python programmers all the time. So let's have a look here at this. Let's set a variable a here equal to decimal. Oh, actually, before we work with decimals, right, we've got to do an import. So let's do from decimal import decimal object. Okay, so now let's do this. A equals a decimal, and let's say 0.0404. Okay, now remember that when Python interprets this, it's going to notice this 0 point and then some other numbers after that and automatically evaluate that to a float. And then what's going to happen is it's going to convert that float into a decimal. Now let's do this b value here, and let's say decimal. And I'm going to actually send it a string data type this time. Alright, now, actually, let's show me A. Ooh, look at that big old thing. And then let's take a look at B. Now, both of these are decimals. See, they're decimal object types. But notice the difference in their values, right? When Python converted this float to a decimal, that binary math caused this type of number to occur. Or this type of numeric, I should say. But when we gave it a string to convert, we got the more accurate, or another way maybe you might think of this is the we didn't have to bring in all these other extra trailing parts of the number, right? It went exactly interpreted the string and converted that to the decimal that we want. So if this is seeming a little confusing, or you still want to know more about this, I encourage you go back and reread the numeric types in Chapter 5. This is specifically covered under decimal basics. Well, if you see, actually, it's what under other numeric types, and then it'll cover the decimal type, and then look at the examples that Lutz has in there with the decimal basics. He goes over in a little more detail about how to add decimals. And actually, I'm gonna pull one of his examples right off there, where he's got the 0.1s minus the 0.3. So let's just look at how that math is different. See, now when it works with decimals, Python gives us that 0 value we're looking for. Actually, let's rewrite it this way here, just so you guys can see. So I got my C value right, so C equals that. Now watch what I can also do. I could say, give me an int of C. And now I'm back to 0. So these are some tips that you're going to need for the task 5. Make sure that you're using the right data type in the right location. Otherwise, what's going to happen is you may make it through some of the tests with the small numbers, like numbers you might be throwing in there like 1,000 or some odd dollars and a certain level of interest rate. But when we test your application, we're going to go for some very big numbers. And if you're not using the right data type, your numbers are not going to equal what they should be with those larger numbers, because those larger numbers are going to push any kind of inaccuracy up to the front, right? It's going to make any kind of inaccuracy is going to be even grossly worse with larger numbers. All right. Hope this helps. Let me know if you need any other tips.